Dear ladies and gentlemen, this is the work. Its title is Complex Processing of Solid Fuel and Plasma Chemical Reactor. So you can see that we present here different institutes. First of all, it is Combustion Problems Institute and Research Institute of Experimental and Theoretical Physics of Al-Farabi Kazakh National University. So that is a collaborative work, and it is about coal and its processing. So here you can see that proven reserves of fossil fuels worldwide. You can see that coal is the main resource for energy. Here is just a comparison of coal and oil, fuel, and gas. We can see that coal is more than twice, for example, oil and gas together. And for Kazakhstan, that is traditionally that we have a lot of coal, but all our coals are rather low grade, and the main problem is that is high ash content of these coals. For example, one of the biggest reserves of coal in Kazakhstan, they have more than 40% of ash content. And here you can see the composition of this coal, and here you can see also 40% of ash content. And so we offered technology for plasma processing of coal together with reducing of mineral part of coal. And first of all, that is, you can see thermodynamic calculations just to show you what can happen with the increasing of temperature using plasma. Here you can see gaseous phase which we have when we have high temperature for this initial composition of coal. 100 kilogram of coal and 40 kilogram of steam. So you can see that in the gaseous phase, first of all, we have synthetic gas and almost synthetic gas, and that's so. And in high temperature, from mineral part of coal, we can see we get some elements. So because in the mineral part of coal we have the whole earth, and in the gaseous phase it will be all in it. That is a condensed phase of the coal. During the increasing temperature we have all the components in the gaseous phase. And in the figure on the right, you can see that the gasification degree can be reached up to 100 degrees. So that is not just calculations. We have experimental part of this work, and here you can see layout of plasma installation for processing of coal. So coal, that is a powder of coal, it goes through from that solid fuel dust hopper to the plasma gasifier or reactor, and inside of this reactor it is gasified, and there we can get synthesis gas and all other components in the gaseous phase. After that we have chambers for synthesis gas sampling and cooling, and then we withdraw to the atmosphere, and here we have catcher for slag. The main element of the installation, that is a reactor, as I said, and here you can see that it is, unfortunately that is not work. Here you can see rod graphite electrode and cathode isolator, and that is a ring graphite electrode. The arc is rotating inside of this reactor using coil, and inside of this reactor we have rather high temperature, that is about, for example, 3000 degrees centigrade. And here some photos of the installation, laboratory installation. Here you can see the sparkle of the arc inside of the electrode through the window for measuring temperature. And here you can see the reactor, and that is a tube for cooling and sampling probes, and that is a slag catcher. And during the experiments we produce all the material and energy balances for getting these experiments. And some results. A Laurent coal of 28 content chemical analysis you can see here, and some main indexes of coal plasma comprehensive processing, or complex processing we also call it. So consumption through that plasma gasifier was 7 kilogram per hour of coal and 4.5 kilogram per hour of steam. Power of the reactor, electric power, was 60 kilowatt, and specific power consumption was a little more than 5 kilowatt per hour per kilogram. And temperature, average mass temperature inside of the reactor was 3100 Kelvin. And here you can see what we have in the outlet of the reactor. That is a synthesis gas, which has more than 90%, and gasification degree was more than 93%, and desulfurization of coal was 95%. And here the last table shows us a reduction degree of mineral matter of coal in different parts of the reactor. So that is from slag of the reactor, and from wall of the reactor, and stuff from slag catcher. Here you can see that we reach up to 47% of reduction for the mineral parts of coal. And one more complex processing of coal. We have in Kazakhstan one more problem with coals. We have, as I said in the beginning, a lot of coals, but all of them are low rank. And one more problem is that we have a lot of coal which have uranium in their content. That is a problem because we can't incinerate uranium containing coals, so we can't do nothing with them. And we offer the, again, complex processing technology for using of these coals. Here you can see a reserve balance of coal in Kazakhstan is 33 billion tons, and almost half of them uranium-bearing coal, and that is just, we can't use them. So the same plasma reactor, that is just scheme. Here we have a plasma reactor, steam, coal, which goes to that reactor, and after that the products of the gasifications goes to the tube with heat exchangers, and molybdenum, uranium, and vanadium from gaseous phase condensate and condensates in different temperatures. So we can get separately molybdenum, uranium, and vanadium. And of course, at the same time, synthesis gas. So we produced some experiments using uranium-bearing shale. And here you can see the table, what we got in the results of these experiments. So degrees of reduction of uranium was up to 78%, molybdenum 79%, and vanadium was up to 81%. And degrees of carbon gasification, you can see here, was not as high as in the previous coal, but rather high at the same time, up to 70%. And you can see also the temperatures about 3 and a little more, 1000 degrees Kelvin. And here just figures flame from synthesis gas from high-ash Kuchikinsky coal. Here you can see gas composition. And that is a flame from uranium containing Kularka-Mindl coal. And here you can see gas composition. And in the conclusion, I just write, the fulfilled computational and experimental investigations demonstrated that during comprehensive plasma processing of solid fuel, its organic matter converts to synthesis gas, while its mineral matter to a range of valuable components. The high calorific value synthesis gas produced by this process can be used for synthesis of methanol or as high potential reducing agent instead of blast furnace coke, as well as for power generation at thermal power plants. Thank you very much for your attention.